Okay, so 3.1 Extrema. You will notice that we are every day in assignment. It is important that every day you are doing your assignment. You will use today for tomorrow, tomorrow for the next day. This builds. You have to have today for tomorrow. You have to have tomorrow for the next day. It doesn't work. So okay, nice of you to work. Okay, so extrema is a relative mins or max. We're relative because we can have more than one, yes? Okay. And that's peaks and valleys. It's decreasing to a minimum, and then it starts what? Increasing. Your theorem down here is telling you that if f is continuous on a closed interval, a, b, then f has both minimum and maximum in the intervals. A and b, these are x values. We talk about intervals only in terms of x's. They're x values, and a or b could be your min or max. Okay, so we will be checking that. So it says find the derivative at each relative extrema. So I need to do what? Find the derivative. I need to find the derivative and plug in the x. The x and y. Probably not going to have the y, but if it's an implicit, yes, then you would plug in the y. So I'm going to have to use...
draw these graphs?
No. I'm going to have to use what rule?
Quotient.
The quotient. So I have f of x equals 9 times x squared minus 3 over x cubed. I personally, for this one, would just keep 9 out. You could put it in if you want. I guess you can put it in if you want. So this would be 9x squared minus 27, wouldn't it?
Yeah.
Okay. So I need to take the derivative of the numerator, which would be, I guess I should probably put my derivative, huh? 18x times my denominator minus the derivative of the denominator times the numerator. Again, that 9 didn't have to be put in there, but you would have to keep it around over the denominator squared. So that quotient rule is not going to change. What I do it on is going to look different. But I just kept numerator, denominator, and I didn't pay any attention to what it was. So what do I get? 18x to the 4th. And over here I'm going to have negative 27x to the 4th plus 181 plus 81x squared. Over x to the 6th, but we could combine, couldn't we?
Yeah.
Okay, so 18 minus 27 is 9.
Wouldn't it be negative 9 though?
Yes.
Why is it x to the 6th?
Because when you square x cubed, you multiply them. So we have negative 9, x to the 4th plus 81. X squared. Okay. Can I reduce?
Yes.
I can reduce out an x squared, can't I?
You had a 9, can't you?
No, because there's no 9. I could factor it out. Is that what you meant?
Yeah.
Okay, so if I factor out negative 9x squared.
Well, then wouldn't...
Go ahead. We'll finish. So negative 9x squared, so we have x squared minus 9
Yeah.
over x to the 6th. Now can I reduce more? Can I reduce this x squared and 2 of these down here?
Yeah.
Yep. So I have derivative of f is negative 9 times x squared minus 9 over x to the 4th. And now we need to find f prime of what?
3, 2.
Just 3. There's no 2. There's no y in there.
But if there was, we would.
Yeah. So 3. So we have negative 9 times 9 minus 9 over over 81. So my numerator is all just what? 0. So the whole thing is what? 0. So the slope right here at this point of this line is what? 0. So that means it is a horizontal line.
What's on the bottom of that?
81. I was going to write it out, and I'm like, wait a second. 3 to the 4th is 81. So that's going to tell us more about it. We had a rule for that, didn't we?
Is that our answer?
Yep, because it says find the derivative of that.
So we're just finding the derivative and then using the x, plugging the x.
Well, this is just the starting point of it. This is just the starting. Okay? It says find the derivative at the relative extrema. So right here, what is the derivative at the extrema? 0. Because it's a peak. Because it's increasing till there, then it's going to do what?
Drop.
It's going to decrease. So right there is a maximum. What would happen at a minimum? Should it be exactly the same thing?
0.
Yes. When we graphed our derivatives, what did we do to those? We brought the min and maxes down to the x-axis because they were zeros, weren't they? Okay.
I'm
What?
just so confused on how, like on the graph, it doesn't look like 0.
No, the slope of that line is 0. So that's telling you is that is an extrema. When your value at the derivative is 0, then it's an extrema. That's what your box is
Are you talking about
right here.
the definition for extreme?
Okay, the definition, but it leads into the critical number. The critical number says, you guys are looking at that definition? Let f be defined at c if f prime at c equals 0, or if it's not differentiable at c, then c is a critical number, meaning it is an extrema. Okay,
So
and
this
then
one was an extrema.
yes. And it told you it was. It told you find it at an extrema. We weren't looking for it, but we're going to be looking. So when that happens, then that's what it is. I'm going to go back up to the other examples. So this says find the derivative again. Is this a continuous function? You guys have to remember back what to continuous meant. No holes and no what? No sharp turns. Is there a sharp turn?
Yes.
Yes.
It's an absolute value.
Okay, it is an absolute value. There are sharp turns there. So is this function continuous? No. This function isn't continuous. And if we look at it, the limit as x approaches 0 from the left, meaning our slope, is what? What is our slope of that line on the left? -1, isn't it? What is it from the right?
1.
+1.
Yeah, positive.
So is this a continuous function? No, because from our limit section, we learned that if they're not the same from the left and the right, is it continuous at that point?
Wait, can you just refresh my brain on why the limit is negative?
Because the slope is what? -1. This is the parent function for absolute value.
Why can't it be like -2?
Well, it could be, but this is just absolute value of x.
So that,
The slope of the absolute value of x is -1 and 1.
so then the reason,
Anytime it's an absolute value, it's not continuous because there's a what kind of term?
I think she's asking, like, how you know it's -1.
I just counted it. Well, first of all, it's the parent function. That's how I know. That is how I know that the slope is 1 and -1, because it is the parent function. How, if I didn't know that, I would count the slope. Right here from this point to this point, what's the slope? Up 1, left 1 is -1.
I can't see no red. The only red that I can see is like on the line, like where it's going right here.
Yes.
But I can't see no other red.
What do you
Maybe
mean?
I'm blind, but I can't see red.
Here's a point and here's a point.
Yeah, I couldn't see that red on the 0.
Okay, what's the slope between those 2 points?
1.
It's -1 because it goes down.
It could also go up.
Yeah,
if you
but
look
it
at
could-
No. If I go from, I'm going to go from this point to this point. It's rise over run. Down 1, right 1. So it'd be negative 1 over 1. If I go from up 1, left 1, it's positive 1 over negative 1. So it's either way, it's what? Negative 1. Now on the other side, what's the slope? Up 1, right 1. And then, or you could go right 1, up 1, but either way, the slope is what? 1. Okay, so this is not a continuous function. It is a discontinuous function. I'm recording. Thank you very much.
Anytime.
Thank you.
Yep.
So, since it's not differentiable at 0, 0, because that's the point it's talking about, can I do this? No. Okay? We have to identify those discontinuous functions and be able to say, nope, it's discontinuous at that point. I may be able to find a derivative, but if it's discontinuous at that point, then we're done. Okay, our next example of this one is find the derivative at the extrema. This is, you're going to have problems like this, exactly like it. Okay, I have two extrema, yes?
Yep.
Okay, I have a min and a max. I need to find the derivative, and then I need to plug in pi over 2 and 3 pi over 2. So what is the derivative of sine?
cosine.
Cosine. So I have the derivative at pi over 2. So the cosine at pi over 2 is what?
Negative 1.
What?
Why is it 0?
Because pi over 2 is 90 degrees. What's the x at 90 degrees?
Negative 1.
The
Wait,
x
90?
at 90 degrees. What is the point up here, Riley?
0.
It's 0, 1.
Mm.
Okay. So then I have
I'd-
what?
Never mind.
And then I have 3 pi over 2. So that's down here, yes?
Mm-hmm.
What's that point?
0.
0, negative 1. So the cosine at 3 pi over 2 is also what? 0. Okay, these are extrema. So what is the slope of the tangent line at these points?
0.
0. So that tells you they're extrema. I mean, obviously it told me they were, so I had to find it.
So if it ever says find the derivative of the extrema, the answer is 0.
Yes, but it's not. You're going to use that. You're going to use the fact when you find that it's 0, you're going to use that to know it's an extrema.
Okay.
Like it introduces it to you today, but that's not the application of it.
So are we gonna get any that don't equal 0? Like,
Yeah, you're going to have to find the extrema. You're going to have to,
Is the extrema always going to be 0?
the slope at the extrema is always going to be 0. Yes.
Okay, then what's the extrema?
Mm-hmm.
Like, you're saying, like, find.
Can we get there? You guys are jumping ahead. You're putting what ifs out there, and we're
I don't
jumping.
even know what we're doing right now.
We're finding the derivative, and we're plugging in the x values.
Yeah, I'm just asking questions.
so you're
about-
I know, but you guys are trying to jump ahead, and I don't want the what ifs because you're going off.
I didn't know we were jumping.
That's why I was trying to.
so we're finding the slope of the tangent line at the extrema.
Right there, we're verifying it that it's 0.
Okay.
That's
already
all
know
we
it's
were doing.
0.
We already know it, but we're verifying it.
So we need to know how to do this for future.
Yes, because the next problem is going to make you not do. You're going to have to know that from your answer. Okay, so a critical number again is a very important thing because we are going to be finding critical numbers every single day from here until the end of the chapter. A critical number, what does this say right here?
If the derivative of c to 0.
Okay, so you're going to find the derivative and set it equal to 0, and you're going to have your critical numbers. The other thing is, though, or if
F is
not
not different.
differentiable. That would mean a sharp change, like right here on this picture. Is it differentiable at that point?
No.
No.
What is differentiable?
You can't find the derivative. It's not continuous. You cannot find the derivative of this function at that point. You can find it everywhere else, but not at that point, because at that point it's not continuous. Okay? The other thing that happens is, what if I would give you an equation that had x minus 2? Would I have a problem with this equation? What happens at 2 of this function? Whatever this is up here, I don't care. What's my problem with that?
0.
It's going to make, at 2, x equals 2 is going to be a 0, which would be a vertical asymptote,
Why?
because it makes the denominator 0 and you can't divide by 0. This is stepping off of what we did in pre-calc when we graphed rational functions. We're graphing rational functions. We are stepping every day further into that process. Okay, the capstone of this is you are graphing rational functions. Okay, so relative extrema, the min and max are critical. If f has a relative min and max at x equals c, then it is also a critical value. All it's saying is, can a critical value be a maximum or minimum? Yes, that's all that's saying. This is the most important thing of that. So, nuts and bolts of what you're going to be doing today is right here. Guidelines for finding extrema. You are going to be looking for extrema. That's what you're looking for. Okay? So, you are going to, on a closed interval, a, b, these are x values. You need to write that if you don't know. X values. You're going to find critical numbers. We're going to find critical numbers by finding the derivative, correct? So we just went through that. So you're going to find the derivative. And then evaluate the critical number. So find the derivative, set it equal to 0. And then you're going to plug that into f of x. Okay, what does C pound mean? Because I'm not going to...
Number.
What number? What C stand for? Critical number. That's how we are going to write critical number. I think the book maybe does CN. You could put CN if you want. C pound is good for me. Okay, evaluate those, and this evaluate your endpoints.
So critical numbers are the derivative.
The zeros of the derivatives. Critical numbers are the zeros of the derivatives. Okay, so find the extrema. I personally do the endpoints first. That is what I like to do first. That list, put them at the bottom.
Can I
Okay.
write this quick?
Yep. Says find the extrema for f of x equals 3x to the fourth minus 4x cubed on the interval of -1, 2. None of these problems change. You only difference on any one of these problems from here until the end of the examples is how you find the derivative. You will do the same steps every single. You got me?
So
Okay.
I'm gonna set it equal to 0.
You gotta find the derivative of it.
Okay, do you guys want, I personally like to do the endpoints first. Okay, because then, why did it jump on me? Okay, so I just write endpoints so I know what I'm doing. I'm going to start with the left endpoint, hence the L. What is the left number, -1 or 2? -1. So f of -1, so I plug it in. So 3 times -1 to the fourth is 1, minus 4 times -1 to the third is -1. So I get 4 plus 4 is 8. So f of -1 is 8. R stands for right endpoint. So I plug in 2. So f of 2. is 3 times 2 times 2 is 4 times 4 is 16. Minus 4 times 8. So 48 minus 32. Just going through the motions and plugging it in. 48 minus 32 is what, 16? Okay, so I have my left and right endpoints. Now I'm going to find my derivative. Find your derivative. So you should have 12x to the third minus 12x squared, correct? Okay, so it said then set it equal to 0 to find your critical numbers. So 0 equals, and is there something in 12x cubed minus 12x squared?
12x squared.
So 12x squared. So that leaves me with what? X minus 1. So I set both of these things equal to 0, and I get x equals 0 and 1. Correct?
Hmm? Wait, what?
I set both of these factors equal to 0 and get 0 and 1.
So 12x squared equals 0 is equal to 0?
Yes,
How?
because 12x squared equals 0 is 0, because you divide 0 by 12 and get what?
0.
And the square root of 0 is 0. So now what does it say I do with these things?
Plug in.
Plug into f of x. So I have f of 0. So that gives me 0 minus 0 is 0. And then I plug in 1. So that gives me 3 minus 4, which is negative 1. Now, we need to evaluate these numbers. We have 8. We have 16. Those are my endpoints, yes?
Negative
And
1
these,
16.
since these right here, the derivative equaled 0 there, we have extrema. Well, we have changing. We have relative. We have 0, 0, and negative 1. So, which is my minimum number?
Negative 1.
Negative 1. And you're going to write min next to negative 1. What is my maximum number out of all 4 of these numbers? 16. So, guess what you're going to put next to 16?
Can I write it off to its own? Can I write negative 1 equals minimum 16?
If you want.
Yeah, I do.
I think in the like if you look at Calc chat, I think they line these up as negative 1 and then 8 and 0, 0 and 1, negative 1 and what's next? 2? 2, 16. And they write min.
Wait, do we have to do that?
And they write max. No. If you had to do that, I would have showed you that at the beginning. I'm showing you how they do it. Like they put this all in a table. And I think to put it in a table is more work trying to organize yourself. We're going to have to organize ourselves other ways. So every problem that doesn't ask to find the extrema or find the derivative at the extrema, this is what you're doing. Okay?
You bringing your homework to work or what? I'm thinking about it.
Okay, so the next one, I'm just going to show you. The next one was the first thing you're going to do. You're going to do endpoints, yes? And then you're going to find the what? Derivative. And then you're going to set the derivative equal to 0.
Plug your x's
And then you're going to plug your zeros back into the function, and you're going to identify the what?
So is that
the
all
max
that's gonna be on the whole
and min.
resume?
Yes.
Exactly like those.
Yes.
No.
You will have
There's so many then.
because you need to practice the routine because you need to get it down.
Yeah, Maddie. You
Plug
need
the
to
zeros
practice
into the
that
original function.
Yes. Now I am going to tell you, what if I get two negative ones? Can they both be minimums?
Yeah.
Yes, because they're relative minimums now. We have more than one can happen. Like when you were first learning min and max, only one could happen at a time.
But you're looking for both max and mins. Like,
Yes, you're looking for both max and mins. What I'm saying is if two of your quantities are the same, like you came out -1 and -1, you could identify them both as minimums. Okay? Now I'm going to tell you there are some trig ones in there, and there is a double angle trig. Try it, and then we'll ask a question on it tomorrow. I want you to...
I'm gonna be here tomorrow. I'm gonna be dead.
I want you to start every single one of these problems so we have somewhere to go off of.